So these phase diagrams starting to finally make a little bit of sense for me. This is for like say RLC circuit. We'll take your current and well, usually we're going to look at some kind of driving EMF. So let's say we're just looking at this one right here. It's going to be a capacitance driven circuit. So mainly capacitance on this side. Let's just say there wasn't even an inductor or something. So your driving EMF will be on this side. And then that'll have some sort of a cosine with a driving frequency and maybe even a phase angle or maybe no phase angle. So let's go with no phase angle. We're just giving a driven EMF. So from there, if we want to get a current, we have to, well, keep in mind that we're on this side. Let's follow this little arrow. We have to add a phase angle. So we'll take the same driving EMF, driving frequency, and then we will add phasing. And then let's say we wanted to calculate the voltage for the capacitance, the capacitor itself across the capacitor. Then in that case, we will take that phase angle that we just added, and then we have to subtract, because we're going this way, to get the capacitor voltage, half the pi over 2. Okay, and okay, so now let's reverse all this, and let's just say we were given a driven EMF here with a driving frequency, and then it has no phase angle. If we want to figure out what the current is, then we have to go this direction by some phase angle, negative. So now we're looking at the current with some minus phase angle. And if we want to figure out what the voltage across the inductor is, now we have to add, because we're going this way, pi over 2. So this is how we can get the 3 different types of voltages. um, and so yeah, so it's pretty crazy. I'm talking about this driven EMF or the driving frequency and stuff. So usually it's given, and if it's not given, then you know you might have to consider if you don't have a driving frequency, then what might happen is you have a decaying frequency, right? So you have the driving frequency here, WD, which comes from this EMF right here. This is the driven EMF. Or if you don't have this driving situation happening, then it'll be a decay. And if it's a decay, then it's going to be kind of complicated other stuff that you have to do over here. But it's not really a big deal. We're going to focus on just this driving frequency stuff here. It's usually given to us. And we are going to essentially hope that there was no phase angle associated with the EMF. If there is, then you just have to start with that. Either add or subtract the phase, but it's just a little bit simpler if we have no phase angle for the driven EMF. Hopefully this made a little bit of sense. I call this an LIC diagram because it's just LIC, and it's not too hard to remember. The L is on this side, the I is in the middle, and then the C is on the right, and this just shows you the 90-degree differences between all 3 of those. The voltage across the resistor is always in phase with the current. So those 2 guys are always going to be along the same phase angle. So hopefully this is kind of helpful, and thank you so much for watching. If you want to download one of these sheets, make sure to check out freephysicsmap.com. And yeah, hopefully it's pretty cool stuff. Thank you all for watching. Have fun.